If there is a wound, scratch, a bite, a cut in your skin, then this is the possibility. This offers a possibility for pathogens to enter the body, and in order to prevent this, the blood has to clot, and the blood clot also prevents excess blood loss. So I'm going to make a little drawing over here. Let's say that this is my skin over here. And there is a little cut. I'm going to make it really very clear. You have a blood vessel over here. And of course, this blood vessel is also now cut open. And what you have is you have now blood spilling out of the cut and accumulating over here and bleeding. But what will happen is the following: a blood clot will form. And this blood clot will then prevent pathogens from entering the skin, and it also gives time to the body to form new tissue and to heal the wound so that the blood can flow normally again. And new cells are made over here, and the blood clot essentially serves as a temporary plug, so to say, to block the entry of pathogens and blood loss. Now, the question is now the following: how does this happen? I remember many years ago, when I was still much younger, we learned in biology class and also read in books that the blood clots when it contacts oxygen, because there's air here. And there's, of course, oxygen gas here. And what the people thought is that the blood goes out, it comes in contact with the oxygen, and then it forms a blood clot. And that is not correct. As a matter of fact, it is much more complex, and that's why we have a drawing over here on the right side. I'm going to now explain you what causes the formation of a blood clot. And then I will also explain a little bit why it's got to be that complex as it is. So first of all, it is not triggered by oxygen, but by damaged tissue or platelets. These are the platelets are floating around inside the blood. These are also known as the thrombocytes. And these thrombocytes or platelets and also the damaged tissue, they release chemicals called clotting factors. So the damaged cells release these clotting factors, and these clotting factors now activate the so-called the prothrombin activator. It's another substance. The clotting factor switch on the so-called prothrombin activator. And what does the prothrombin activator do? The prothrombin activator now converts a substance called prothrombin, which can be found floating around inside the blood. It converts it into the active form, which we call thrombin. So what we have is we have a sequence of steps here. The damaged tissues release the clotting factors, they switch on the prothrombin activator, and the prothrombin activator switches on, yet again, the prothrombin to form thrombin. And now what does the thrombin do? The thrombin, now being active, is able to switch on fibrinogen, which can be found, believe it or not, floating around inside the blood, and converts the fibrinogen to an insoluble active form called fibrin, and that's the blood clot. So you have over here essentially the fibrinogen, which are floating around in a soluble form inside blood, and because of the thrombin, it starts to form networks and fiber. And this is then the actual blood clot. Oops, now I switched foils. I'm giving away something over here. Okay, so we're back here. So that is the blood clot. So that is what you call a cascade. And now the question is, of course, why do we have to have this cascade? And why can you not just start over here from the damaged tissue? We skip all of these things here, and we just use the clotting factors released from the damaged tissue directly to activate fibrinogen. Why do we actually have all of this detour Why can we not just go directly? And one of the reasons is because in a cascade where one substance switches off on the next substance, you have a magnification, or rather not a magnification, an amplification factor. So even if you have very few damaged cells, it will activate some of the prothrombin, but this one is able to activate many more prothrombins to form thrombins, and this thrombin is able to activate many more fibrinogens to form fibrin. So we have an amplification, or an amplification step everywhere here. And in reality, the whole thing is even more complicated, because what the body has to take care is that it really, the blood clot only forms if you have a wound, it should not happen that the blood starts to clot inside your blood vessel in here. Then you have a problem, which I'm going to talk about in the next foil. But that's something that should not happen. And in order to control the blood clot formation, there are many possibilities for the human body to influence this cascade, to regulate the blood clotting. So that's basically the background purpose, or the hidden purpose behind having such a cascade. It's amplification and also for better control. And now I'm going to show you the next foil. And we talk about coronary thrombosis right now. And that's basically when a blood clot starts to form inside a blood vessel. So what we have over here is we have the cross section of an artery. And that's one of the coronary arteries over here. I do not know if you've already seen my video on the coronary arteries, but in any case, that's a coronary artery supplies the heart muscle itself with blood, and that's a cross section over here. And what we have is we have the lumen inside. We have the endothelium, which is a thin layer of cells covering the inside of the blood vessel. We have muscle fibers, longitudinal and circular muscle fibers, and we have also an outer layer. And what happens is, and now I think I have to switch the color again, is I'm going to show you now what happens if there are deposits and if there's a blood clot forming. Let me quickly switch the color to, let's say, black. Okay, here we are again. Now you can see it much better. So what we have is we have deposits, and over the weeks, months, whatever, you start to form on the inside of the artery, inside the lumen. That's supposed to be my lumen. That's where the blood is flowing. Okay, you start to form deposits, and these deposits start to increase. And the lumen becomes smaller and smaller and smaller. And now there's a problem if you have these deposits. Of course, it blocks the blood flow directly, because it makes the diameter smaller. I'm just gonna draw it like this as well, and like this. But at the same time, the blood is not able to flow smoothly anymore, and there are turbulences, and the blood starts to not slow down. And as a consequence, when the blood does not flow smoothly, then this can also encourage the formation of a blood clot. So what we have, they're not only these deposits of, let's say, cholesterol or whatever, but essentially over the time we start to form blood clots as well. Okay, how am I going to label this here? Clot. Okay, so, and when this happens, then the lumen becomes smaller and smaller and smaller, and until it blocks the blood flow. And if this happens over here in one of these coronary arteries, I'm just going to draw a big dot over here to indicate that there's a blood clot over here, and then the blood is not able to flow, and essentially there is all these parts over here are not supplied by blood anymore. You can see all these blood vessels which branch off, all the capillaries over here, not supplied, and then you have this whole region over here, essentially all of this dying off, and that's what you call a heart attack. And of course, it goes without saying, depending on where you have this blood clot, this can either affect a large or a small region of the heart. So, what does this have to do with the defense against infectious diseases? Because that's the chapter where we are in right now. This example of coronary thrombosis, as it's called, is simply an example of where you have something which is actually normally important, blood clots. If they happen at the wrong place, then they can cause a problem. And that's essentially how this idea is linked. Blood clotting as a means to protect against infectious diseases and to prevent blood loss, but also as has a negative aspect to it, that blood clots forming on the wrong places, called thrombosis, can cause heart attacks. And over here it says fibrillations. These are irregular heartbeats. So that's basically it. You got to remember this here. You got to remember the sequence of steps over here in the cascade during blood clotting. That is important because sometimes the multiple choice questions which ask for the correct sequence. Okay, that was it.